Hello everyone, this is Akang Suman here. Now we are going to discuss the next topic, that is simple gear trains. We have classified the types of the gear trains into four categories. The first is simple, the second is compound, the third is reverted, and the fourth is epicyclic. So one by one we will discuss. So first I am going to consider the simple gear trains. What is the meaning of the simple gear trains? Simple gear trains means one gear on each shaft. Okay, one gear on each shaft. So there is only one gear, only one gear on each shaft, one gear on each shaft. So that is known as the simple gear trains. Okay, simple gear trains. And these we all know that the gears are specified there by their pith circle. If you go to the shops and ask them to buy gears, then you need to tell them the diameter of the pith circle. Okay, that is the size of the gears. So that means the size of the gear is specified by the diameter of the pith circle. So that is why pith circle is the biggest circle. It is an important circle, and it is an you know biggest circle of the gear. So distance between the two shafts in the simple gear train is small. You can see here the distance between the two shafts is the this shaft, this is the first shaft, and this is the final shaft. First and final I'm saying because this is the main driver. Okay, I'm just to transmit the power from this one shaft to the third shaft. Okay, this gear you can see here, this is known as the intermediate gears. Okay, intermediate gears or idler gears, you can say this is the intermediate gears. There may be a number of intermediate gears, intermediate gears. Okay, there may be a number of intermediate gears. It depends on the distance between the driver gear and the driven gear. Okay, so simple gear trains means there is the distance between the two shafts is small. Okay, when the first and the two gears are in mesh with each other to transmit motion from one shaft to the another shaft. Okay, and since we are transmitting power from one shaft, this is first shaft to the finally third shaft, this is the main driver and this is the main driven. Why I am saying this is main driver and this is main driver? Because there are a number of intermediate gears in between them. So there for them, so there are a gear, there are a number of driver, there are a number of drivens for the gear trains. But main driver will be one, and the main driver will only be one. Okay, so for example, let us understand. See, this is the driver, this is the another gear, this is another gear, and this is another gear, and this is finally another gear. So this is the, why I am saying this is main driver, because see, this is 1, this is 2, this is 3, and this is 4. Because for three the driver is 2, and for 3 the driven is 4. Okay, because 4 is driven by gear 3 and the gear 2 is driver for gear 3. Are you getting my point? See, in 2 and 3, which is driver? 2 is driver and 3 is driven. In 3 and 4, which is driver? 3 is driver and the 4 is driven. So that is why I am saying this is the main driver, and this is 5, this is the main driven. Okay, this is main driver, and these 2, 3, 4s are called as the intermediate gears. Okay, another thing you must have to remember that the speed of the gear is always inversely proportional to the number of teeth. Okay, so that is why if I want to find out the velocity ratio omega 1 upon omega 2, that would be T2 upon T1. T2 is the number of teeth on the gear 2, T1 is the number of teeth on the gear 1. So it can be right as it is. Okay, and if you want to know the velocity ratio between the gear 2 and the gear 3, so it would be like that: gear 2 upon gear 3, that is omega 3, and that would be T3 upon T2. Are you getting my point? So the direction, if I'm talking about the direction of the gears, the driver is in clockwise direction. You can see here the main driver, the gear 1 is in clockwise direction, so it would be in anti-clockwise direction. Meshing, the mating gear would be in anti-clockwise direction. If it is in anti-clockwise direction, that would be in clockwise direction. So here you can see, if the number of idler gears, I am writing here, if the number of idler gears are even, in the next page I can write that if number of idler gears even, okay, if at number of idler gears are even, then we can say direction will be opposite. What direction? The direction of the main driver and the direction of the main driven will be in opposite. Okay, but this is when the number of gears in even means there is 2, 4, 6 like that. Okay, if the number of idler gears are odd, number of idler gears, or you can say number of intermediate, both are same. If number of idler gears odd, so that means direction will be same. How it is possible? See, in the example that we have considered, this in this diagram, the idle gears only one. There is only one idle gear. That means the idle gears are odd. Odd means 1, 3, 5, 7 like that. So number of gears here, number of idler gears here is 1. That means the direction will be same. So here you can see there is a driver direction is the clockwise, and finally the driven direction will be clockwise. So that's why direction will be same for driver and the main driven. If the number of idler gears are even, here you can see I am going to consider an example. This is the first gear, and this is the second gear, and this is the third, and this is finally fourth. Here there are intermediate gears which are 2. Okay, this is one intermediate gears or idler gears, you can say. So what would be the direction of main driver and main driven? If this is in clockwise direction, this would be in anti-clockwise. Okay, if this is in anti-clockwise, that would be in clockwise. If this is in clockwise, that would be in anti-clockwise. So you can see here the main driver and the main driver are in opposite direction, because the number of idler gears between them are even. Okay, so that is 2. If this is a number of idler gears are odd, then the direction will be same. So you just have to remember this concept for the direction. Okay, and you all know that the speed ratio, I already told you, this is known as the speed or velocity ratio. Speed ratio. Okay, speed ratio, and it is always inversely proportional to the number of teeth on that gear. Speed ratio. Okay, so thank you. I hope you will understand the simple gear train. One gear on each shaft. Okay.